So this one is that third circumstance where you have kind of, I like to call it an improper fraction with the degrees. We have a 2 on the top and a 1 on the bottom. See, a degree of 2 on top and a degree of 1 on the bottom. That'd be a 1 right there. So that's 2 over 1, which means that there's no horizontal asymptote. So you're going to find a horizontal asymptote? There's none. But there is an asymptote that goes from left to right and up and down at the same time. And that's called the slant asymptote. Now you only get a slant asymptote if you have a degree on the top that's bigger than the degree on the bottom, like in this one. The degree on top is 2, the degree on the bottom is 1. This is what you do when you have that. You divide. You actually have to divide this out using long division or synthetic division, whichever one you like to use and whichever one you can use, to find your slant asymptote. Okay? You guys ready for this action? So, because the denominator is x equals 1, because there's a 1 in front of for the leading coefficient, that means I can use synthetic division, which is what I want to use. So I put 1 in the multiply box. You know, you always do the opposite of what's right there. And then you have 1, -1, and -2. That comes from this guy, 1, and -1, and -2. Okay, finish setting it up. Got my dotted line, so I know where my remainder is. I bring down the first one, I get a 1, then I get a 1 right there because I go 1 times 1, I get that 1. And then I add those two together, I get 0. 0 times 1 is 0, and then I have -2. So we have a remainder, and I know this is a 0, but I'm going to still write it out just so I don't confuse anybody. This is plus -2 over x minus 1, because that's the remainder. The next number is our constant. That's just going to be 0. And then the next number is 1x. So there's your 1, your 0, and your -2. Now, we don't care about this, because as x gets bigger and bigger and bigger, this approaches 0. As it gets bigger and bigger and bigger, this whole fraction approaches 0, which makes sense because if the number on the bottom is getting really, really big, it's becoming a smaller and smaller number. Watch, like if I had 1 over 2, and then 1 over 3, and then 1 over 4, what's happening to these numbers?
They're getting smaller.
Yeah, they're getting smaller and smaller and smaller. Because 1/7 is definitely smaller than 1/2. It's just going to go to 0. It's going to converge to 0. So we don't care about this numerator, or this remainder. We care about this. That is your slant asymptote. Your slant asymptote equals y equals 1x plus 0. Now, you don't need a plus 0 because, you know, it's plus 0. I'm just writing it because I want to remind you guys, this is the y-intercept, and this is your slope. If your slope is an integer, just throw a 1 underneath it, so you have a rise over run. And so your slope would actually equal 1 over 1, so that you know you go up 1, then right 1. And so we start at 0. You used to always start at a point somewhere on the graph, and since we know the y-intercept is 0, we're going to put it right there. Then we go up 1, right 1, up 1, right 1, up 1, right 1, up 1, right 1, and then we have our line. Down 1, left 1, down 1, left 1, down 1, left 1, down 1, left 1. And we can connect the line by using a dotted line. Connect the dots using a dotted line. And that's your slant asymptote. Is there a vertical asymptote for this one?
Yes.
Oh, faux show. Vertical asymptote. To find vertical asymptotes, you take the denominator and set it equal to 0. And our denominator is x minus 1. We set that equal to 0. We got x minus 1 from this guy right here. And then we solve it. X equals 1. That means at x equals 1, we have a vertical asymptote. So I'm going to go, see, x equals 1 right there. So I go dot. So there's my asymptotes. So what's my graph going to look like? This is kind of interesting. I haven't seen anything like this before. Your graph can go like this and like this. Or it can go like this and like this. Okay, we just have to find out where those lines are. Now before, you know, when I was telling you guys how to graph, the next thing we would do is what? Do you guys remember?
Intercepts.
Yeah, we would find the intercepts. Alright, so the next thing we would normally do is we would find the intercepts. But I'm not going to find the intercepts right now. I'm just going to do the points, okay? You normally you need to know how to find the intercepts, which is just, you know, plugging in 0 for the x to find the y-intercepts, and then plugging in 0 for the y to find the x-intercepts. you can do that, but I kind of explained that more in detail in the other videos, so I don't want to waste time doing that here. Let's just pick some points. Alright, we got to pick some points on this side of the asymptote, the vertical asymptote. Then we got to pick some points on this side of the vertical asymptote. And I'm not really looking at the whole graph. I'm just looking at the x-axis, and I'm looking at the x-axis on that side. So let's pick 0, -1, and -2. You probably really only need 2, but I'm going to pick 3 just because I like to see for sure like where my points are going to go. If I pick 0, what would I get? When I plug a 0 into this, what would I get? Let's see. We would get 0 minus 0 minus 2 over 0 minus 1, which is -2 on the top, -1 on the bottom. What do we get? We get dou. So we actually get some pretty clean numbers when we do this. It's kind of nice. -1, when I plug in -1, that's going to be +1. And then if I plug in -1 to that right there, that would also be a +1. And subtract 2, and then I have a 1. Actually, it's a -1 minus 1. So I get -2 on the bottom, but that doesn't matter because at the top, that becomes 2. 2 minus 2 is 0. It's 0. So I have 0 right there. And don't get confused, guys. You guys are getting used to like doing things undefined. If the 0's on top, it's 0. If the 0's on the bottom, then it's undefined. If I plug in -2, let's see how we get 4 plus 2 minus 2. And those cancel out because they're the same. Well, it kind of look like x's now. Cancel out. And then the bottom I have -2, and I subtract 1, so that's going to be -3. And on the top I get 4. All right, is my math correct? So that's -1 and 1/3. I don't like looking at improper fractions when I have to graph. I like to make mixed numbers that are easier to graph when they're mixed numbers. 0 to 2. 0. So I go to 0. 0, 2 is 0, 1, 2 right there. And then next one is -1, 0, which is right there. Wow, that's really close to the asymptote. And the next one is -2, and it goes down -1, 1/3. Oh, that's interesting. Okay, so this is what our line looks like. And just to make sure, let's pick a couple other points on the other side of the asymptote. I'm pretty sure the line's going to go like this. But we'll make sure. Okay, let's see. Let's plug in. We can't plug in a +1, but we can plug in a 2. We can plug in a 3. Let's plug in the 2. Can someone else plug in the 3 so I don't have to do it when I get to it? When I plug in a 2, let's see. Plug in a 2. Plug in a 2. Plug in a 2. So I plug in a 2, I get 4 minus 2 minus 2. And on the bottom, I get 2 minus 1. On the top, I get 0. On the bottom, I get 1. 0 over 1 is just 0. All right, what did you guys get when you plug in 3? You got 2? Okay, so I have 2, 0. So 1, 2, 0. And then 3. Wait, what'd you get? 3 got 2? All right, cool. Looks like that's where our graph is. And so we just have to connect those dots, stay close to the asymptote. Now this is technically not right because you see how this line right here starts coming off the asymptote? That shouldn't be. It should keep getting closer and closer to the asymptote. But I don't know. This is just a rough sketch. It doesn't have to be perfect.